Good evening, students. Today we are going to discuss senior chemistry long answer questions for organic chemistry, physical chemistry, and inorganic chemistry. Most important 10 LAQs today we are going to discuss. So, without wasting our time, we'll start first physical chemistry. See that what is electrolysis and state Faraday's electrolysis, and one problem is given. See all of you, what is electrolysis here? Electrolysis, the decomposition of chemical compound in the molten state into constant elements and under the influence of applied EMF is called electrolysis. That is here electrolysis. So we can say sodium chloride, potassium chloride, any electrolyte can be, we can go for electrolysis. Here first law of Faraday. What is electrolysis? State law of Faraday. First law we will discuss here. See first law here. According to first law of Faraday, we can see mass is directly proportional to the quantity of electricity. Here mass of substance M means Q means quantity of electricity in coulombs. So here where we need to discuss clearly, that is here mass is directly proportional to the quantity of electricity. Second law also very related to that of first law, but here there is no current that is depend on mass, but here very important 2 marks question also they are going to ask you this question, that is here directly they are asking what is Faraday of second law, Faraday first law, like that. Here same quantity of electricity passed through the different electrolytes connected in series, the amount of substance liberated at the electrode is directly proportional to equivalent weights. Here directly proportional to equivalent weight, there directly proportional to the quantity of electricity. See this quantity of electricity passed through the electrolyte. That is a major difference. In first law, mass is directly proportional to the quantity of electricity. In second law, see in second law, this the amount of mass deposited at electrode is depend on equivalent weights. That is simple difference between first law and second law. They given one problem. See that problem based on the first law. See problem is based on first law. But this equation is second law. M1 by M2 is equal to E1 by E2. That is second law for right. But here the problem is given based on first law. That is for problem 2 marks question. Solution is 1 mark question. That is totally 2 marks question. They are asking according to board of intermediate. Okay, students. See the problem. What is given here? M is equal to E into C into T by F. That is a simple formula. Atomic weight into coulombs. That is in current and time in seconds. So we can say here F means 96500 coulombs. So that is copper atomic weight is atomic mass or gram atomic weight 63. That is current is given 1.5 and time is given here 600 seconds. So you can substitute all the values. You can see current also given, time also given. You can substitute here. You will get the answer is 0.293. This is a simple question based on the first law of Faraday. If you know the formula, easily we can get the answer. Nothing is there. But we need to learn first law and second law. Then one problem will be added. That is here our question. Right? First question is completed. Second question. State and explain the Kohlrausch law of independence migration of ions. Very important. Sometimes they are giving here A, B, two questions. No? So sometimes they are asking A or B, like that also they are going to ask you. See here, what is Kohlrausch law? The equivalent conductance at infinity dilution of electrolyte is equal to algebraic sum of cation and anion. So that is here equivalent conductance at infinity dilution is sum of, that is what type of sum? Algebraic sum of equivalent conductance of cation and anion. That is your simple formula of Kohlrausch law. Clear? So it is mostly it is for dilute solutions or dilute solution at infinity dilution. Infinity means at last we are adding so much water. That type of dilution is called what? Infinity. So here mathematically Kohlrausch law is written as a, see that electrolyte For example, sodium chloride or potassium chloride, whatever it may be. So that is equal to cation plus anion. That is algebraic sum. Clear, friend? That is lambda naught is given. Naught means infinity dilution. At infinity dilution. Clear? The infinity dilution sum of cation and anion. Algebraic sum of cation and anion. That's it. So this is a simple formula for the Kohlrausch law. Clear? Yes. Now you can see here whatever values are there, we need to write in a symbol, that is the cation, equivalent conductance of cation, equivalent conductance of anion at infinity dilution, and equivalent conductance of an electrolyte at infinity dilution. That is a simply we can write electrolyte, and first one is cation is there, cation is there, that is cation, and next one is you can see anion is there, and electrolyte is there. So algebraic sum of cation and anion is equal to what? Equivalent conductance of electrolyte at infinity dilution. That is a simple formula. Clear? So you need to write clear information. Next one, equivalent conductance of ion is also directly proportional to mobility of ion. Mobility means how much speed they are moving. So that is here we can see two equations are there. Cation, that is K, is directly proportional to velocity. Clear? K means constant value, directly proportional to the velocity. Clear, friends? So here both cation and anion both can be written as a similarly cation and anion both can be written. So that is here equivalent conductance is directly proportional to the mobility of cation and mobility of anion. That is a simple equation about here Kohlrausch law. Clear? So that is Kohlrausch law. Now we'll go for applications of Kohlrausch law. Whatever applications are there, we'll discuss. This is also very important for LAQ. Okay. So see this. Molar conductivities of weak electrolyte at infinity dilution. This also simply they are asking application 2 marks question. Okay, what are the applications of Kohlrausch law? Okay, student. Now you can see we can determine the limiting molar conductivities by using Kohlrausch law. Limiting molar conductivities of weak electrolyte. The spelling is missed here. That is weak. Weak electrolyte. Clear? That is not will. This is weak electrolyte. So we can calculate limiting molar conductivities of weak electrolyte. Okay. See here the value of lambda infinity of weak electrolyte cannot be calculated directly because we are adding so much water solvent, then the electrolyte is dissolved and dissolved. The ions are very far one to other. That time unable to calculate this is directly by using any other principles. But by using Kohlrausch law, easily we can calculate limiting molar conductivities of weak electrolyte. But in any other method, it is impossible. It is only possible by using Kohlrausch law. That is one application of Kohlrausch law. You can see here, we'll take one application. How to calculate limiting molar conductivities of weak electrolyte. This is the best application. See, I am taking acetic acid, that is acetate plus H plus ion breaking. Now without using acetic acid, we can calculate molar conductivity of acetic acid. That is a Kohlrausch law application. See, I am taking here sodium acetate, HCl, sodium chloride. These all are strong. These all are not weak. But I am making here algebraic sum. You can see breaking of this one, sodium acetate, acetate ion, sodium plus ion, H plus ion, Cl minus ion, and algebraic sum means plus or minus. So we can remove sodium chloride from this. Add sodium acetate and HCl, subtract sodium chloride. So we'll get here sodium remaining, sodium plus, and you can see sodium minus. Both are get cancelled here. Algebraic sum means plus and minus, both ions will be get cancelled. You can see here sodium acetate is left now, that is acetate is left and H plus also left. Remaining you can check it out here, Na plus Na plus, Cl minus Cl plus. So here both are get cancelled. We'll get at last acetate ion. Like this we can calculate here weak electrolyte conductivity. Without using weak electrolyte, we can use here related compounds of that and we'll get the weak electrolyte limiting molar conductivity. Clear? Next one, dissociation constant of weak electrolyte. Dissociation constant means K. K means dissociation constant. So that is for acid and base, both are there. For Ka acid, Kb for base. So your dissociation constant also can be calculated by using our Kohlrausch law. How we know here, alpha we know, degree of dissociation. If degree of dissociation means breaking of ion. If you know that one, you can calculate with the relation with a K. You can see here equation. K is equal to C alpha square by 1 minus alpha, where alpha is equal to what? Degree of dissociation, right? C is what? Concentration. So by this equation, we can substitute here. See that? So alpha is equal to what? Alpha is equal to what? So uh, molar conductance of your equivalent conductance or molar conductance, and these molar conductance infinity dilution. Molar conductance are given by infinite dilution. So at last we'll substitute this value. K is equal to C into molar conductance of its square after substitution of that one by molar conductance infinite dilution into molar conductance infinite dilution minus molar conductance of the given electrolyte. By this equation, we can calculate constant value K. Okay, equilibrium constant or K dissociation constant can be calculated. That is about Kohlrausch law. Next one, give the details account of collision theory. That is chemical kinetics. Very important question this is. So that is for we can discuss about bimolecular and trimolecular, all these things. Listen first one by one. What are the important 9 points of this? This is LAQ, most important LAQ. So many times asked this question. See this. Reacting molecules are assumed that spheres. A reacting molecule will have to collide to form products. Two reacting molecules colliding each other. Then what happens? All the collisions do not lead the formation of products. See, this is very important. All the collisions do not lead the formation of products. Only fruitful collisions lead the formation of product. Now, the minimum energy required colliding molecule to give the product is called threshold energy. Very important, is 2 marks question also. So okay, and additional energy supplied to reacting molecule to reach threshold energy is called what? Activation energy. The molecule is also called activated molecules. So these two definitions are important. Clear, student? Additional energy required. That is here activation energy. So activation energy is equal to, that is threshold energy minus energy of normal molecule. That is ER. EA is equal to ET minus ER. ET means threshold energy. ER means normal energy. See this, normal energy of molecule at standard temperature and pressure. So that is the activation energy formula. Next, fifth one. The molecules which possess threshold energy are called activated molecule. Just now I said activated molecule must possess threshold energy. Clear, student? What is this threshold energy? Minimum energy required by the colliding molecule to give the product. That minimum energy is called threshold energy. So compulsory active molecule required threshold energy. Next one, threshold energy. Clear, students? Next, we'll go for here sixth point. See this sixth point. Activated molecules collide with each other, and these collisions are called active collisions or activated collisions, or we call effective collisions. So whenever these activated molecules are there, these two are collide each other, then that collisions are called effective collisions or fruitful collisions or activated collisions. So that collision is will get the products. See this, due to these effective collisions, product are formed. So all students are writing exams means they won't get the ranks. That means all the collisions do not lead the formation of product. Who will get the rank? Fruitful collisions, those who are getting a proper collision, proper study, proper interaction, proper lesson planning, that type of students only getting results. Here also molecules which having effective collisions will give the products, other molecules do not give the products. Clear, students? So this is given by our Arrhenius equation. You can see that is ZAB is equal to collision frequency, and here reaction of A and B. Just now I said the expression is rate is equal to ZAB into e to the power of minus EA by RT. This is a rate expression for Arrhenius equation, where EA is equal to fraction molecules of energies are equal to or greater than activation energy. EA, activation energy. This equation also important. Now we'll go for your ninth point. A reaction takes place only when reacting molecules are collide with proper orientation. That is very important. See the diagram, you will get the idea. What is meaning of proper orientation? Student also will get your proper idea, proper concept. Then only will get the seat in mains and also IIT and even any competitive examination. Clear, student? So you can see a best example. I took either methyl bromide with any base like OH minus. See here proper orientation is not there. There is no product. There is no product. If proper orientation is there, there is a product. Their intermediate is formed followed by product is formed. If any 6 points are enough to get the 8 marks in this question. So these all are very important points for the collision theory. Don't forget to learn all these things. Clear, friend? Now we'll go for immediately next question, third question. That is sometimes they are giving here 3A. So sometimes they are asking and B question also, that is A and B. So C is given as a B means it is a mostly they are asking as a 4 marks question but added to LAQ. Very important. So what is the question? What is the molecularity of reaction? What is the molecularity of the reaction? You can see this molecularity of the reaction, and how is it different from the order of the reaction? That is nothing but difference between order and molecularity. And asking name one bimolecular and one trimolecular gases reactions also. This also will get very important, and they will ask you 1 or 2 marks question. Sometimes they are asking 1 or 2 marks question. Don't forget. We'll discuss one by one. See this, what is the first molecularity? What is the order of the definition? So we'll go for here. First, uh, reacting molecule. Number of reacting molecule or atoms or ions species which are present in the rate determining step or elementary reaction is called molecularity. Nothing but number of molecules, number of ions are involving the rate determining step, or we can say elementary reaction is called molecularity. Clear, students? Similarly, we can go for order of the reaction. What is order of the reaction? See, the sum of the sum of powers of concentration terms of reactants in a rate equation is called order of the reaction. The sum of powers of concentration terms of reactants in rate equation is called order of the reaction. And molecularity already we discussed. See, above one is as it is molecularity of the reaction. Here, order is written by experimentally. We may not calculate theoretically, but molecularity we can calculate here theoretically by using reaction mechanism. Reaction mechanism. Okay, students. And one more thing is very important here. See, order may be whole number, zero, fraction, negative. Very important. Order may be zero order, first order, second order, negative order. But here molecularity may not be zero, may not be negative, but always it is whole number. Don't forget this. Molecularity will be always whole number. Clear, friend? Next one. Next one you see. It is applicable for elementary reaction as well as complex reaction because order is so complex we cannot calculate. But here molecularity is only elementary reaction, simple reaction. A plus B gives rise C like that. But this is not easy. It is very complex and also sometimes elementary type. So this is the difference between order and molecularity. Very, very important here. 4 points. If you want, you can add one more point. Order not exceed more than 3. Molecularity also not exceed more than 3. These points also we can add. Clear? Next one. What is bimolecular? What is trimolecular? See example. Two molecules are involving, that is bimolecular. If three molecules are involving, that is 2NO plus O2, three molecules, that is trimolecular. This is yes, this is 1 mark, that is 2 marks. Mostly this is also carry marks, okay, in IP examinations. Don't forget this trimolecular and bimolecular reaction. Clear, friend? Got it? Next we'll go for your fourth question. How is ozone prepared? This is inorganic chemistry. Physical chemistry is over. How is ozone prepared from oxygen? Explain the reaction with the ethylene, potassium iodide, mercury, lead sulfide, silver. We'll discuss one by most important from inorganic chemistry question. So many time asked this question our board of intermediate. Okay. mode of intermediate. Principle. See what happened when dry and cold steam of oxygen is subjected in a silent electric discharge tube. That is the instrument here. Siemens ozonizer we are using. Which ozonizer? Siemens ozonizer. So in this Siemens ozonizer we are taking oxygen. This oxygen is subjected into the into the ozonizer. It undergo silent electric discharge. Then it is converting into ozonide oxygen. Convert into what? Ozonide oxygen. Ozonide oxygen. That is nothing but in ozone little amount of oxygen also present after preparation of ozone. That is nothing but ozonide oxygen. Clear? So here how much ozone is formed here means just 10% only formed, not 100%, not 90%. Okay, that is here. What is the reaction? See, 3O2 gives rise to O3. Simple. So it undergo silent electric discharge. Clear? So here it is a endothermic reaction. It is what type of reaction? Endothermic reaction. That is nothing but it absorb energy. It required energy to convert oxygen to ozone. That's why it undergo silent electric discharge. Clear, student? That is it release plus it required plus 142 kilojoules per mole energy to convert oxygen to ozone. That is an endothermic reaction. Don't forget this is a endothermic reaction. Okay, student. Now we'll see. We'll see now. Most of the reactions also very important. This what we just now we discussed is mostly it is they will give 2 marks or 3 marks. So you mention here 2 marks only. Okay. So now reactions of this. First one ethylene. See ozone react with the ethylene and form ethylene ozonide in the presence of ozone and zinc plus water. This is reductive ozonolysis. What is this? And formaldehyde will be given. What will form here? Formaldehyde is formed. See the reaction once. How reaction will be there? See ethylene it is, and ethene IUPAC name react with ozone and form ethylene ozonide. This is ethylene ozonide. See here, this is called what? Ethylene ozonide. This ethylene ozonide is looking like a bommarillu. So this is undergo hydrolysis in the presence of water and zinc metal. This process, whatever hydrolysis is there, this is called reductive ozonolysis. Reductive ozonolysis will give you aldehydes. That is here formaldehyde will give. So 2 moles of formaldehyde and this oxygen go with the water and form hydrogen peroxide. See this oxygen go with water and form hydrogen peroxide. Simple, clear, friend. That's it. So that is a completely analysis. Next one, reaction with potassium iodide. Ozone oxidizes potassium iodide to iodine. Very easy question. See this moisture. Moist means little amount of water. So we are adding little amount of water to potassium iodide in the presence of ozone. It converting into iodine. Very important point here. See all of you. All reactions, whatever we can see now, that is B, C, D, all. We can observe only one thing. O3 converting into O2 first. See the reaction. Observe here. Ozone converting into O2. Clear? That's why ozone oxidizes. Ozone oxidizes. We can write common point here. Ozone oxidizes means ozone losing one oxygen and giving two other compounds. So that is ozone converting into O2. So it lose one oxygen molecule. Clear, friends? That's why it is oxidizes. Got it? Now reaction with the mercury. That is here ozone react with the mercury and give mercurous oxide. It loses its meniscus nature and stick to the walls of the glass plate or glass vessels. That is very important. Actually mercury we may not touch. It will be breaking into small spheres. But whenever it react with the ozone, then it loses that nature and stick on the walls. This process or this phenomenon is known as tailing of mercury, tails sticking on the walls. Reaction very easy. See that 2Hg plus O3 gives rise Hg2O plus O2. See ozone converting to O2. That's it. Next one PBS. Oxygen and ozone both are we can see O3 converting to O2. That is a common. Here PBS is converting into what? Sulfate. That is sulfide to sulfate. Lead sulfide to lead sulfate is formed. Clearly you can see here. PBS, lead sulfide. react with the ozone, 4 moles of ozone, and form here 4 moles of oxygen. That is O3 to O4, O3 to O2, and PbSO4, PbSO4 sulfate. See, that is here compared to other equation also. Yes, yeah, this is here. Clear? O3 to O2, right? That's it. So this is the all reactions we can observe O3 converting into O2. That is a common. That is a common. Clear, friends? Next we'll see. Next we'll see. Um, Next reaction with the silver. Ozone oxidizes silver metal to silver oxide, similar to mercury, same as it is. Need not to discuss more. 2Ag plus O3 gives rise Ag2O plus O2. Same reactions. No much. So this is also 1 mark. Don't forget. Each reaction carries 1 mark, students. That is about here. Ozone is over. Clear? Ozone is over. Each carry 1 mark. Next, fifth question. How chlorine is seventh year group elements. How chlorine is prepared in the laboratory? How does it react with the following? Following means we have iron. We have iron here. Iron. Hot concentrated sodium hydroxide. Acidified ferrous sulfate. Iodine. Right? Iodine. And also we have H2S and sodium carbonate. These all are we need to discuss one by one. First preparation. How to prepare? Two methods we can discuss. How many methods we discuss? Two methods we'll discuss. First one you can see all of you concentrate here by heating manganese dioxide with concentrated HCl. MnO2 manganese dioxide with concentrated HCl will form here MnCl2 plus Cl. That is very important. Cl2 is liberated. It is a laboratory technique. We are going to see in a lab also practical examination. We can see this one. Next, second one, the mixture of sodium chloride and concentrated H2SO4 on react with the manganese dioxide will give you chlorine gas. See 4 moles of sodium chloride, 1 mole of manganese dioxide, pinch of manganese dioxide, black powder, sulfuric acid, we get MnCl2. Liberation of Cl2. That's it. These two are 2 marks question. Preparations are 2 marks question. Don't forget this. Now we'll go for chemical properties. First one, reaction with the iron. Iron react with the chlorine, that is Cl2, 3 moles, will come here, ferric chloride. So ferric and ferrous, very important here. FeCl3 is formed. That is called ferric chloride. Simple reaction. No much difficulty here. 2Fe plus 3Cl2 gives rise to 2FeCl3. That is number of moles will be balanced. Very important this one. Reaction with the hot ion concentrated and cold ion concentrated. Two conditions are there. But here only given hot ion concentration will discuss. Hot ion. Chlorine react with the hot ion concentrated sodium hydroxide gives sodium chloride and sodium chlorate. See this. Sodium chloride and sodium chloride. This is NaClO3 is called sodium chlorate, student. Very important. See this. Yes. So this one. Yeah. We'll change the color. Na. Yes. 1 minute. NaClO3. This is sodium chloride. So in a hot condition, we'll get here sodium chloride is formed. Don't forget this one. Next reaction with the acidified ferrous sulfate solution. See, ferrous sulfate is converting into ferric sulfate in the presence of chlorine. Clear? So in the presence of chlorine gas here and also acidic conditions, that is addition of sulfuric acid, acidic medium, ferrous sulfate react with the chlorine and form ferric sulfate. Ferric sulfate. That's it. Nothing is there here. Clear, right? Yeah. Ferrous sulfate to ferric sulfate is formed. Okay, students. So next we'll see. Next we'll see here reaction with the iodine. All of you concentrate. Reaction with the iodine. So moisture chlorine again here. Moisture means nothing but we are adding little amount of water. Whenever we are adding little amount of water to any compound, generally we call here moist. Moist chlorine oxidizes iodine to iodic acid. Very important. Iodic acid formula you can see here. HiO3, iodic acid. Iodine to iodic acid. Okay, sir. See here the reaction I2 plus water and chlorine will form here HiO3, iodic acid. Okay, so iodine react with the chlorine in the presence of little amount of water will get here iodic acid. Got it? Next one, reaction with the H2S. Reaction with the H2S. See what happened here? Whenever chlorine oxidizes iodine to sulfur, that's it. H2S react to the chlorine and form sulfur. See, that is just sulfur is formed. H2S to sulfur is formed. Okay, student. Next, last one, reaction with the sodium sulfite. See, moisture chlorine again, it's react with the sodium sulfite. Will get here sodium sulfate and also sulfur. Sodium sulfate and sulfur is formed. Don't forget this. Moisture means little amount of water is added. Clear, friends? That is it. See here. See, Na to S2O3 converting into Na to SO4. Na to S2O3 to Na to SO4. That is sodium sulfide to sodium sulfate. This is also each reaction is 1 mark. Don't forget this. Next question is how chlorine is prepared by electrolytic method. Explain its reactions. Whatever reactions are there, we can explain. Whatever reactions, standard reactions, sodium hydroxide, ammonia under different conditions, that is sodium iodide, liquid lime, calcium hydroxide. So these all are will discuss. First principle will see. Principle. See, in a principle, we are using a brine solution. What is brine solution? Brine solution means 10% sodium chloride is commonly we got brine solution. 10% sodium chloride is called what? Brine solution. Don't forget. So here this is Nelson cell. Mostly this is very important in even first year also. But now second year also sometime they are asking these preparations. Okay, very easy question. All of you concentrate. In this Nelson cell, there is one is cathode and anode. Cathode and anode. Don't forget here. Okay, what is cathode? What is anode? We'll discuss first. See, this vessel is a contain here. Um, Mostly a vessel is suspended in a rectangular iron tank. Rectangular iron tank it is. Okay, see this rectangular iron tank. Here a carbon rod, that is here we can say graphite. It is dipped in a mostly brine solution which is act as a anode. Which is act as a anode. So carbon rod or graphite rod is act as a anode. Okay, friend, that is carbon rod or we can say graphite rod is act as a anode. Don't forget this. Okay, this is a act as a anode. Okay, now we'll see what is cathode. Yeah, your iron or steel vessel u shaped steel vessel inside lined with the asbestos we are adding in a line, that is that steel vessel is act as a cathode. Clear? Yeah. Now we need to see here steam is forced. Steam means water vapor will be forced in this cell. That is also one important point. Very important this one. Last one, that is very important. Steam means water vapor. Water vapor. Clear? Now we can see whatever reactions are taking place here. Whatever reactions are taking place, whatever products are formed. In electrolysis, we'll get here Cl2 gas, sodium hydroxide, H2. Three compounds are formed. That's why it is important in seventh year group element, and also it is important in first year sodium and its compounds and hydrogen compounds. So these are three lessons this question will be come across. But in second year, seventh year group elements, chlorine preparation we are discussing. So reactions here at anode, what happens? See, so oxidation taking place, that is chlorine is liberated. At cathode, see this H2 gas is liberated and also form sodium hydroxide. This is reduction reaction. These two are very important. First one is ionization, second one anode reaction, third one is at cathode H2 and sodium hydroxide is formed. Clear? H2 and sodium hydroxide formed. Totally in this reaction, in this Nelson cell, we'll get here three products. One is sodium hydroxide, H2 and chlorine. These three products are formed. You can see the here this picture once I will explain labeling all these things. So this black one is there. This is called here carbon rod. which is act as a anode, right? Here inlet, that is for brine solution we are adding from here. This is here perforated U tube is there, asbestos lining inside, but outside is perforated U tube. It is a steel vessel. And here from outside we'll get here chlorine gas, inside brine solution. And one more is here you can see 1, 2, 3. So some numbers are there. It will be labeled under this diagram. All of you see this one by one. Perforated steel U tube, that is here, which is act as a cathode. Act as a cathode. That is easy. This is U tube and act as a cathode. Next, asbestos lining. See inside slow dots are there, black dots. Yeah. These are here asbestos lining to the U tube. That is perforated U tube. Perforated means holes containing brine solution. Just now I informed 10% sodium chloride brine solution will be added into the electrolytic cell. Next one, sodium hydroxide is formed. That is as a product at the bottom of the U tube. We can see chlorine inlet, chlorine outlet. See chlorine gas is absorbed by the anode and sent out through the this small outlet. That is chlorine gas is out. Next, next one we can go for here. Uh, Hydrogen outlet. Hydrogen gas is also formed when steam is entered in the chamber. Then the steam is react with the sodium ions which are coming out outside chamber. So then this from the brine solution, this is react with the steam and converting into sodium ions. The remaining hydrogen will be out. So like this, first one chlorine, second one hydrogen, last one here sodium hydroxide is formed. Steam inlet, just now I said. See, steam means water vapor is sent. Then that water vapor react with the water and form sodium hydroxide, remaining is out. So here last one is brine inlet, just now I said. Brine inlet means brine solution will be added. Clear, friend? So last one you can see graphite anode. Graphite anode also there. Just now the black one is graphite anode. Clear? This is your complete information about our Nelson cell process. Preparation of chlorine, remaining byproducts also. Clear, friend? Check it out once. Yes, this is anode, cathode, all these things. Yeah, this is reaction will carry 1 mark. Don't forget. Next, we'll go for chemical properties of chlorine. Yeah, reaction with the sodium hydroxide. Chlorine react with the cold and dilute sodium hydroxide and will form here sodium chloride, so hypochlorous acid. That is sodium hypochlorous acid. Now, sodium hydroxide react with chlorine and form NaOCl plus. Previously, we discussed the same one. See above preparations. See this here hot and concentrated condition we'll discuss, right? Sodium chloride is formed here, but here we are discussing cold and dilute. Here hot and concentration. Hot and concentration will get here sodium chloride. See here cold and dilute will get here what? Okay, sodium hypochlorous acid will form. Don't forget here, right? Chlorous acid is formed. Sodium chlorous acid, right? Next to hot and condition again he repeated. You can see here down. Hot and constant is also repeated. Here dilute and cold will get here NaOCl. But here see hot and constant 2 times this question is this answer is repeated up and down. So once you learn these two, you can write anywhere. Sometimes they are asking 2 marks question, you can also give answer. Here, see this, see cold, hot and condition, more concentration. That is 2 NaOH, 6 NaOH. Here we'll get here NaOCl. Sodium chloride is formed. Don't forget cold and dilute, hot and concentration. Two reactants and two products are different, right? Number of moles also change. Reaction with ammonia, very easy, and there is specially mentioned two conditions, that is excess of ammonia and excess of chlorine. Excess of ammonia will get here ammonium chloride. Ammonium chloride. Wherever we are taking 8 moles of ammonia, we will get here ammonium chloride and N2 gas also form. Here you can see N2 gas and ammonia is formed excess of ammonia. But here second one excess of chlorine I am taking here. Excess of chlorine. There excess of ammonia here. But in second one, excess of chlorine. These two conditions very important. In objective also so many times asked this question. Complete the reaction. A plus B gives rise C. What is this? Okay, don't forget. So here on excess of chlorine we get here sodium trichloride. Sorry, nitrogen trichloride. Nitrogen trichloride NCl3 will form. That is very important reaction. Next one, sodium iodide. Chlorine react with the sodium iodide give the sodium chloride. and also form iodine gas, liberated iodine gas. Simple reaction it is. 3NaI plus L2 gives rise to NaCl plus I2. Last but not least, reaction with the slake lime, that is calcium hydroxide, will give bleaching powder. Calcium hydroxide means CaO plus H2O will get a lime water. Lime water is commonly we called slaked lime. Slaked lime. Slaked lime react to the chlorine gas will get a bleaching powder. You know very well about bleaching powder. What is the formula of bleaching powder? CaOCl2, right? And also water. So this is the important about our.
This is today's class, and remaining we'll discuss next class. Thank you for watching, and don't forget to subscribe. Thank you.